So again, a permutation is an ordered arrangement of events. And this is really important, but you won't necessarily see the difference with this today. Order does matter. So order matters. On Thursday, we're going to talk about when order does not matter. So for all of today, we're talking about order mattering. Okay. So let's talk about how we find out the amount of permutations something has. So Thursday, we were talking about the number of possible ways we could organize something, or what were the possible numbers, or what was the possible. I think there's one that talked about passwords, the possible phone numbers, how many different ways you could answer a test. In most of those situations, order did not matter. It didn't matter what order the things were done in, because we could still answer the same. For instance, for that quiz, we could answer A on all of those. Today we're going to be talking about situations where when you pick an object, it removes it from the pool of possibilities. So the first example we have here is it talks about Ravi's about to eat his top 5 favorite candy bars. His top 5 include Reese's, Snickers, Three Musketeers, Twix, and Butterfingers. And the question is, in how many different orders can he eat all 5 of the candy bars? So the setup for this is really similar to what we were setting up Thursday with the fundamental counting principle, in that I still suggest making boxes for each of the possible spots that you need to fill. So in here it tells us that we're eating 5 candy bars. So we're going to have 5 boxes that we need to find the number of options for. And just like before, we'll be multiplying together the numbers that will go in those boxes. What? Got a pencil, is that okay? Okay. So that part's the same as what we were doing yesterday. Or Thursday, not yesterday. Well, I guess we were working on it yesterday. Now, where it changes is with the numbers that we're putting in the box. So I want to look at this first box. How many different candy bar options do I have to put into this first box? How many? When he is choosing from these candy bars, how many candy bars does he have to choose from? 5. So for the first box, I'm going to label this first bar. He has 5 options. Now the second box is where it deviates from yesterday. So that's actually the same as the fundamental accounting principle. And we still technically are working with the fundamental accounting principle here with the multiplication. But the second number is a little bit different. If he chose one of those 5 candy bars, how many does he have left? He has 4. So when he chooses the second candy bar, he only has 4 possible options left because he'd already eaten one of them. He'd already had one. Then what would be the next box after that? 3. And then I assume you probably have the pattern down now. The next 2 boxes would be 2 and then 1. Now, at this point, we're out of candy bars. He's consumed all 5 of his possible candy bars at this point. So now that we've filled all those spots, we can go ahead and use the fundamental accounting principle to multiply those boxes out.
I just realized that I'm given the untimed ACT
Okay.
in the ISS room, so I guess if I'm needed, that's where I am.
Okay.
I mean, you can tell me and Sharon.
Okay. Sounds good. Thanks for letting me know. Yeah, he'll be down there. Okay, so at this point we can actually multiply it out. Which we do 5 times 4 times 3 times 2. times 1, it's going to be 120. So there are 120 orders that he could eat those candy bars in. Now, obviously, it says top 5. They didn't give us a specific order, but these are the different amount of ways that he could eat those candy bars. He could eat them in 120 different ways. And the reason we wanted to count down is because once he consumes them, he doesn't have it left. Unlike with yesterday where we had a phone number. So when we were talking about phone numbers where we had, 7 boxes, I'm going to write this up here. You don't have to write this down, but I just want to point out the difference between these. If we had our phone number with 7 boxes, we could reuse the same numbers again, right? This first box had only 8 possibilities because it couldn't have a 0, 1. But the rest of these, all the rest of the numbers had 10 options. And that was because we could reuse numbers. We could reuse 0 through 9 as many times as we wanted, other than on the first number where we were limited by 0 and 8. So permutations come into effect when something gets removed from the pool of possibilities that you're putting them into that. So that's where a permutation is different than what we were doing with the basic fundamental counting principle. Does anybody have any questions about this thus far? Does anybody know what mathematical function we use when we do this counting down multiplying, where we do 5 times 4 times 3 times 2 times 1? Or if we had, let's say we started out with a 10 and it was 10 times 9 times 8 times 7 times 6, and then so on down to 1. Does anybody know what that's called? It's all right if you don't.
Factoring down.
Kind of, that's close. So factor is in the word. It's actually on your paper. These are called factorials. They're called factorials. And 5 in factorial form would be 5 with an exclamation mark. So that would be 120. We're going to talk more about factorials in a second. But what we're talking about, a big piece of what we're talking about today is factorials. Because every time we choose an option, we're removing an option from the pool. So we use factorials to represent that. And the factorial symbol is just an exclamation mark. Symbol you're very familiar with, I'm sure.